Hi, it's Susanna with Science with Susanna, and tonight we're going to talk about the shoulder and arm bones. I'll teach you about all the names of the bones and all the markings your teachers might ask you about. Let's get started. Let's look at the right upper limb. First, I want to make sure you know what's what in this picture. And when I mean like what's the right, what's the left? This arm right here, this one is the right arm. Both of them are of the right arm. This one is the anterior view. So you're looking at someone in the anatomical position with their palm facing forward. Then over here, this is the posterior view. So you're looking at the back of their right arm, like they're walking away from you with their palm facing away from you. Starting at the top, this bone right here is the clavicle. You can see it when you're looking straight on. And then if you are looking at the back of the skeleton, you could only see part of it. Next, we'll color the scapula, also known as your shoulder blade. The clavicle and the scapula together make up what's called your pectoral girdle. The word pectoral means wing. So these two bones are going to be the attachment point from which the rest of your upper limb will hang from. The pectoral girdle is lighter than the pelvic girdle, which we'll look at later. Those are where your hips are. Doesn't have to support as much weight as the pelvic girdle. Here's the humerus. From the front, and here is the humerus from the back. Next thing I forgot to color in the scapula over here. The shoulder blade is the other name for that. And the clavicle is also called the collarbone. The lower arm has two bones. The radius right here is on the lateral side, and I always can remember because it's on the same side as the thumb. So when I look at it from the back, see how it's still on the same side? There's the thumb, and it's still on the side as the thumb. So that's the radius. The ulna is medial when in the anatomical position. Has a little styloid process, hangs off right there. And then from the back, it's what forms what you would call your elbow. Big bump on the back of your lower arm. Guess we could put some labels on here. So the humerus, the radius, the ulna, and then you come to the wrist bones right here. Those make up your wrist, these 8 carpal bones. Then we come to what are called the metacarpals. These are also known as your palm bones. You have 5 of these. And you number them starting with the thumb. So 1, 2, 3, 4, 5. And then if we go over to the other hand, it would be like this. So 1, 2, 3, 4, 5. Then those 8 carpal bones. 4, 5, 6, 7, 8, like that. 5 metacarpals. And 14 phalanges, finger bones. You have 3 finger bones on each finger except for your thumb, which only has 2, see? And they're named as proximal, middle, or distal, based on how far away they are. Now I'll point out some joints. Where the humerus meets with the glenoid cavity is called the shoulder joint. It's a ball and socket joint. And what that means is it has the greatest range of motion of the joint types. And actually, this one in particular is the greatest range of motion because the only other ball and socket joint you have is your hip joint, and that one has to be a lot more sturdy and weight bearing. So it doesn't have nearly the range of motion as our upper limb does at the shoulder. This is the elbow joint. Has much less range of motion. Primarily, it's a hinge joint, but it can also pronate, which means that you can like turn your hand upside down like you would be bouncing a basketball. That's the elbow joint right there. Then here we have the wrist joints, and you can see there's a lot going on there. So multiple joints. Wherever a bone encounters another bone, that's going to form a joint. So wrist joints, elbow joint, and shoulder joint. Now, each one of those individually, where these different bones come together, does not have a great range of motion, but all together, they can provide quite a bit of different movement at the wrist joints. And then you have your finger joints. Now we're going to look at the right scapula. On the far left, we're looking at a posterior view. So like you're looking at someone's back and their scapula bones. And this is a right scapula. All of these are pictures of the right. Then this is a lateral view. The purpose of this is to see how the humerus articulates with the scapula. Again, it's the right. They all are. And then this picture on the far right is the anterior view of the right scapula. I'm going to start with the topmost structure on the scapula, and that is a structure called the acromion right here. And that word acromion means the highest point. So you can see it when you're looking at the back of someone's scapula right here. If you're looking from the side, it's up here like this. Still the highest structure no matter the angle. My drawing over here is kind of bad, but this is still the acromion kind of jutting out. And you still see that it's the highest. So that's going to be your dead giveaway when you're trying to identify this. Look for the highest structure when you're holding the scapula in your hand, and the acromion will be the highest structure. And your deltoid muscle attaches here. That's your shoulder muscle that helps you raise your arm. Let's move down now to the next highest structure, which is called the coracoid process. And it got its name because it looks a little bit like a crow's head. So it's called the coracoid process or crow's process. You can see it in all three of these angles here. So you'll find that one by looking for the second highest structure that jumps out. Coracoid process. And it means crow's shaped. Your biceps muscle attaches here. Your bicep helps you to flex your arm and your elbow. The next prominent structure is why I have this lateral view here. So you can see this fossa. It's a depression, and it provides the place for the humerus, which is your upper arm bone to fit, to form the ball and socket shoulder joint. And it's called the glenoid cavity. Sometimes you'll see it called the glenoid fossa. The head of the humerus articulates here. Then I just want to give you a couple of directional landmarks. One is this side of the scapula is the medial border, and then the lateral border is on this side. So just remember to keep that straight. And so then that means if you're looking at it from the front, then it's the other way around, right? And this would be the medial border, and this would be the lateral border. I'm going to dedicate the rest of my talk about the scapula to something called the rotator cuff muscles. The rotator cuff muscles all help to hold the humerus into the glenoid cavity. The first one is above the spine of the scapula from the back, and it's called the supraspinous muscle, and it comes from this fossa above the spine. So this is the supraspinous fossa. And there's a muscle that starts here and it goes over to where the humerus would be fitting into the glenoid cavity, and it anchors the head of the humerus into that glenoid cavity. So rotator cuff muscle number 1 is called the supraspinous. Supraspinous means above the spine, and they don't mean the spine like your back. They mean the spine of your scapula, which I'll color in red right here. So this is the spine, and it juts out. And then it leads, you see how it leads into the acromion? Spinous process. From the side, you can see it here, a little bit of it anyway. And then you can't see much of the spine, if at all, from the front. Underneath the spine is the second muscle that helps to hold the humerus into the glenoid cavity, and it's called the infraspinous muscle. And that means below the spine. And it comes from this area down here called the infraspinous fossa. So these muscles are a little bit on the flat side so that they can fit onto this bone. So this muscle also has fibers that start on the infraspinous fossa, and then they go toward head of the humerus and hold that into the glenoid cavity. The third rotator cuff muscle is called the subscapularis, which means on the underside of the scapula, which really makes sense if you think of a four-legged animal. This would be facing the ground. It's not as obvious on us as humans since we walk upright. But you can at least think of it as on the other side, right? So it is right here. When you're looking at the front of the scapula on a skeleton, then it would be this area here, and it will have a muscle there that has its fibers, once again, are going to go this way, and then they attach to the humerus and hold the head of the humerus into the glenoid cavity. The fourth is the teres minor. Now, this muscle starts on the lateral border on the back, and it has fibers that go up kind of this way to form that fourth muscle. So you see 3 are on the back and only 1's on the front. The subscapularis muscle comes from the subscapular fossa. Here's another look at the pectoral girdle, which includes the clavicle and the scapula. There's a joint where the clavicle meets up with the sternum, and we call that joint right there the sternoclavicular joint. And then you have another joint where the other end of the clavicle articulates with the acromion. And so we call that the acromioclavicular joint. And then, of course, the very important right here, shoulder joint, where the humerus articulates with the glenoid cavity of the scapula. And that's that one that I said is a ball and socket joint, very movable, great range of motion. Now we'll look at the very wonderful humerus. And again, I'm just looking at a right humerus. This picture on the left is from the front or anterior. And then the picture on the right is from the back. It's the posterior. Let's start at the top and color in the head of the humerus. I'm making it blue also because it's covered with articular cartilage, since it is going to be meeting up with the glenoid cavity, and then that will reduce friction. So it's smooth and glassy unless it becomes arthritic. I'm going to keep a running list of all the articulation markings on this side of the page, because there's some of the markings you're going to learn that we learn their names because they're important places where one bone meets another bone to form a joint. And then other markings are important because there were muscles. They are where muscles attach. This particular one with the head is an articulation point. So the head of the humerus articulates with the scapula, and specifically with the glenoid cavity or glenoid fossa of the scapula. Right underneath the head, we call this part the anatomical neck. This little spot right here, anatomical neck. It's one of the places where you will find growth plates or epiphyseal plates where the bone can get longer when you're growing. Now we'll look at the first big bump you'll need to know. This first one is, as being a bump, it's called a tubercle, and we call it the greater tubercle. You can see it from the anterior side. I'm drawing over here on the left picture I have. And then if you look at this bone from the back, you can get a hint of it over here on this side. That's called the greater tubercle. I'm going to keep a list of locations for muscle attachments right here. And as it so turns out, the greater tubercle is an important place for multiple muscles to attach. 3 of those 4 rotator cuff muscles I told you about attach here at the greater tubercle. The only one that doesn't actually attaches right next door at the lesser tubercle, which is another bump. It's just not quite as big. So this is the lesser tubercle that you can easily see. It's a little lower and smaller, and you can only see it from the front. And it is the site for the subscapularis. Remember that the one rotator cuff muscle that's on the other side of the scapula? In between the greater tubercle and lesser tubercle is a valley, and the floor and the sides of that valley serve as attachment points for even more muscles. And it's called the intertubercular sulcus. So inter means between. So this is a valley between the greater and lesser tubercles. And a sulcus means like a valley. We also learn that on a brain, where when you have a valley or a groove, we call it a sulcus. The pectoralis major attaches here. That's a chest muscle to help move your arm. The latissimus dorsi, which is a big back muscle, attaches here to help move the arm. Teres major attaches here. That's different than teres minor. And it works with the latissimus dorsi to also move the arm. And going in this groove is the tendon for your biceps brachii. As we move down the shaft of the humerus, the next important kind of bump or bulge is called the deltoid tuberosity. And like its name implies, it serves as the attachment for the deltoid muscle. This bump that I want to draw next is on the lateral side of the humerus. So then if it's on the lateral sides over here on this one, when you're looking at it from the back, and that's the lateral epicondyle. And it serves as muscle attachment for your wrist extensors. So in order to extend your wrist, muscles attach here. And we've got a big bump on a bump over here on the medial side. So this is the medial condyle on both sides here. And it serves as an attachment for wrist flexor muscles. So that's a lot of muscle attachments, right? So let's see, if I were to go through those one more time real quick, you've got the greater tubercle and the lesser tubercle, which are attachments for your rotator cuff. Then in between them, the intertubercular sulcus, which is an attachment for both chest and back muscles to move your arm. And then the deltoid tuberosity for your major shoulder muscle, the deltoid. Then when we come to the bottom of the humerus, the bump on the outside, the lateral, is where wrist extensor muscles attach. And then the medial bump is where your wrist flexor muscles attach. Next, I want to show you some structures that articulate with the radius and the ulna. So the radius articulates with the capitulum, which is the head down here. That word capitulum, you can remember because it means head. And it looks like a head, doesn't it? Round like that. And it is where it articulates with the radius. Now, before we write that, though, look right above it. I'm going to add some lines to give a little bit more impression that you can see where there's like a groove there. And the radius, when you bend your elbow, can fit right up into this spot like this. So those two structures together help the radius fit. The capitulum and what's called the radial fossa. So these two structures together help to articulate with the radius, lower arm bone. Now let me show you how it works for the ulna. For the ulna, I'm going to use blue again because I like putting blue where we have articular cartilage, nice shiny cartilage that covers the ends of the bones. Just put some dots in there like that. And then you can actually see it from the back side too, unlike the capitulum. like that. That is called the trochlea. And then right above it is a little groove that's called the coronoid fossa. So again, another indent. And this indent is meant to receive the ulna as you bend your elbow. So that's the coronoid fossa. And these two structures together, oh, I guess I could, this is a little boxier looking, right? I had put the dots in. These two markings articulate with the ulna of the lower arm. And then there's just one more to learn. It's on, you can only see it from the back. It's a really deep valley or fossa, and it is going to receive the olecranon of the ulna. So we call it the olecranon fossa. And it is also helping to articulate with the ulna. Actually, I guess I could go like this. All of these articulate, all three of these, with the ulna. So to wrap up, on the humerus, you have 1, 2, 3, 3, 4, 5, 6 major bone articulations that you need to know. And then the muscle attachments, we said there was 1, 2, 3, 4, 5. Should be a 6. Okay, 6. So 6 muscle attachment sites and 6 articulation markings, which means that most students need to learn about 12 markings on the humerus to be ready for their anatomy exam. Now we come to the lower arm, the radius and the ulna. The radial head on this right side of the body is going to be lateral like that. It's going to be on the thumb side. And this is the anterior view. And then looking from behind, you can see the head of the radius right here. The radial head articulates with the radial fossa. On the humerus, when the elbow bends. Then just beside that, you can see the upper lip of what's called the coronoid process. And you can see it when you look at a lateral view of the ulna right here. This lip right here is called the coronoid process. And the coronoid process of the ulna articulates with the coronoid fossa of the humerus. Coronoid process and radial heads. Those are the two so far. Going down a little farther, we can see a bulge on the side of the radius, and that is the radial tuberosity. And this is where your bicep muscles attach. That's why it needs to have a little bit of strength and thickness to this part on the bone so it can withstand the pulling of the muscle. Muscles pull on bones. So this, if you didn't already realize this one's the radius and this one's the ulna. And then I can do the same thing on this side. So this one's the radius. And this one's the ulna. Coming down to the bottom of the bone, you can see little areas that kind of point downward on both bones. And when they're a little bit pointy like this, we call them styloid processes, like a pen or a stylus. So this one right here is the ulnar styloid process. And then this one is the radial styloid process. And both of these serve as attachments for wrist ligaments. Now you can look over on this side. See, here's the ulna, right? And then there it is. There's the styloid process, and then there's the radial styloid process on the radius bone. The back side of the ulna has an extremely prominent feature that you would just call your elbow, and that's the olecranon. And the olecranon fits into the olecranon fossa on the humerus. You can see it a little bit from this side angle too. So this picture I have on the far right, here's the ulna, a lateral view of it. And the olecranon then is this big elbow part that can fit into the olecranon fossa on the backside of the humerus. And then the front of it is the coronoid process, and that fits into the coronoid fossa on the front side of the humerus. Then we call the whole inner part right here the trochlear notch because it fits onto the trochlea of the humerus. The last part of the upper limb that we need to study is the hand. There are 14 finger bones. Your thumb only has 2, like this, but all of the other fingers have 3 phalanges. A total of 14 per hand. Next are the metacarpals. 1, 2, 3, 4, 5. And these would be what you would call your palm bones. Over here on this right picture, this is looking at the back of the hand, fingernail side up, and they would go 1, 2, 3, 4, 5. Then when you look at the back of the hand, this is the thumb, so 1, 2, 3, 4, 5. So you've got these 5 metacarpals. That's all one word, actually, metacarpals. I just ran out of room. Then there are the wrist bones. Wrist is the word carpal. They're right here. And the carpals, or the wrist bones, meet up with the lower arm bones. And so here's the ulna, and here's the radius. And I always can tell which one's the radius because it's the one that's on the thumb side. So same over here on this picture. This one is the radius, and this one is the ulna. So the radius will be the one on the thumb side. Now, let's go ahead and look at the wrist bones. I'm going to teach you 8 wrist bones. 1, 2, 3, 4, 5, 6, 7, 8 wrist bones. Let's start with this one that looks like a boat right here. So get to the base of the thumb. See how it's shaped like a boat? So because of that, it's called the scaphoid. Scaphoid, which means literally boat. So that's the first one. And then go in a clockwise motion to the next one, which will be shaped like a moon. And because of that, it is called the lunate. Lunate right here. Lunate. or moon. Look for one that's shaped like a moon. Then we go to the next one, clockwise direction. We get to one that's in the corner and is called the three-corner triangle bone, right here. And this one then gets named the tricentrum. Tricentrum. So do you see that tri right there? That tells you that it is the three-corner triangle-shaped one. And then sitting right on top of that one is a little pea-shaped bone that of course got named pisiform because pisiform means pea. Look at that right there. Pisiform. Little ball-shaped one, just like the little green pea. Now, moving along to the next one. So see how we're still moving clockwise? Coming around right here, you get to this horrible hook-shaped, scary-looking bone called the hamate, which literally means hook. Here it is. There's the hook-shaped one. So you find that, you'll see that hook coming off. It's absolutely unmistakable that it looks like a hook. So we call it the hook bone or the hamate, which means hook. We're going to keep moving clockwise. And the next one is like the head of all the bones in your wrist. Color this one pink. And it is, like we've also already learned that word, capital means head. And this one's going to then be the capitate bone. See how it's right in the middle of all of the carpals and it has the most like uniform and clearest shape and it's the biggest? So it's called the capitate. Then continuing to move clockwise, we come to a very nice regular trapezoid shape. And so it got named trapezoid because it's a nice tidy rectangle. Sorry, I'm going to put that one in gray. Right next to that, we come to the last one of all. I'm going to make it red so we finish up. And this last one has a really similar name, but I can tell you, I never forget that it's the trapezium instead of the trapezoid, because I remember that the thumb swings on the trapezius, and that's like trapezium. And there's a saddle joint here that helps the thumb be opposable. So we're going to have this swinging motion with the trapezium bone. We'll look over on the posterior side, continuing to go in a circle, but we're going to go the opposite way because we're looking at the back of the hand now. So remember, we start off with the boat-shaped one, right? So that's the scaphoid. Put an S. And then remember, I'm going to go the opposite direction. The next one is shaped like a half moon. The next one is shaped like a tidy triangle. So it's called the tricentrum. And then from this angle, you can sort of see just a bit of the little P, the pisiform, hanging off in that first row, pisiform. And then keep going. The next one around is going to be that horrible hamate. You can't see the hook on this side. You can only see it from the other side. And then keep going to the central head capitate. Then keep going. We're almost done. And we're going to come to the last two that both sound like trapezoid. But the first one is a tidy rectangle. So it's the one that gets to be called trapezoid. And then the next one is more of a swing. So it's the trapezium. And the thumb swings on the trapezium. And there you have it, the bones of the wrist and hand.